in the past few classes, because Prasanna, you are joining very late. So what we have covered till now the constraint motion completely. We have done the different cases of constraint motion. We have also covered different cases of pulley block system. Okay, so this is the type of Atwood machine. This is an Atwood machine where you can see two blocks are hanging from a pulley. Hope all of you are able to see it. You see, this is a pulley, and these two masses M1 and M2 are hanging from it. Now, in this type of system, the question will always be like, they will give you the direction and the of acceleration of one of the blocks. That is, they will tell you whether the M1 block is moving upwards or M2 is moving downwards. Okay, and based on that, they will ask you to calculate the acceleration of the blocks and also the tension. So yesterday we did both of them. We calculated the acceleration as well as the tension, and I already explained you how to calculate. And these are the shortcut formulas. Okay, these two are the shortcut formulas. So those who have missed the classes, you have to see how do I derive at this formula. And for your quick revision, to calculate the acceleration of the system, because see, since M1 and M2 are tied with the same string, okay, this M1 block and M2 block, these are tied both with the same string, so they will both have the same acceleration. ये कॉमन सी बात है, समझ में आ रही है ना? M1 ब्लॉक और M2 ब्लॉक को हमने एक ही स्ट्रिंग से बांधा हुआ है, एक ही स्ट्रिंग से बांधा हुआ है, तो अगर M1 ब्लॉक जिस स्पीड से नीचे जाएगा उसी स्पीड से तो M2 ऊपर जाएगा. और ये भी क्लियर है कि अगर एक ऊपर जाएगा block तो दूसरा block कहां जाएगा? नीचे जाएगा. So this is pretty much clear that since both of them are in the same system, they both of them M1 and M2 block when combined form a single system. So if M1 block move upwards, M2 block will automatically move downwards and vice versa. Is it clear? And they both have the same acceleration and they both will move the same distance in a given interval of time. Okay, so all of that will be same. So based on that, I was giving you a question yesterday. Was giving you a question, na? Okay, for those who have not seen the formula, see, this is the formula to calculate acceleration. जिन्होंने नहीं देखा है, ये formula होता है. कैसे calculate करोगे सिस्टम का acceleration? आप क्या करोगे? M2 minus M1 upon M1 plus M2 into G. ये formula कैसे आता है? इसको आपको recorded lecture में देखना पड़ेगा. ये मैं करा चुका हूँ. Okay, so the derivation of this formula has already been explained to you. But what you can remember, this is the shortcut formula to calculate the net acceleration of this Atwood machine. This is an Atwood machine. Atwood machine. Atwood machine system. What is an Atwood machine? It is a type of system where two masses M1 and M2 are hanged over a pulley. Okay. So yeah. For tension, the formula is the shortcut formula. And I'm just giving you the shortcut formula now. The total or the derivation of the formula I've explained to you in the recorded classes already. So 2 M1 M2 upon M1 plus M2 whole multiplied with G. This is the formula to shortcut formula to calculate the tension. Okay, there will be certain tension in the strings. Why? Because the weight of the blocks M1G is acting downwards. Okay, and because of that, the string will have the tension upward direction. Similarly, here also M2G, the weight of the block will be acting downwards. You can see here I've drawn the FBD. Weight of the block is acting downwards, and the tension on the string is acting in upward direction. And you know why? What is the role of tension? I've already explained you what is tension in the string. So ये सब चीजें पहले हो चुकी हैं कि टेंशन क्या होती है, क्यों ऊपर लगती है, कब लगती है. ठीक है, जिसका ये चीज क्लियर नहीं है, टेंशन क्या है सर, क्यों ऊपर लग रही है, ठीक है, ये कैसे बनता है एफबीडी, वो सब पुरानी चीजें हैं, आपको वो देखनी पड़ेंगी. वो नहीं समझ में आ रहा है तो इट इज नॉट, these are not the concepts of this class. If you are not aware what is tension and how to draw an FBD, all those have been covered in your previous classes. So go watch the recorded session. ठीक है, you have these two shortcut formulas. Based on that, based on these formulas, I have a question for you. Yeah, can you see the question? There are two blocks. One is of 2 kg, the other one is of 3 kg. Okay, and after the blocks, the question says after the blocks are released from rest. After the blocks are released from rest. Released from rest means that the system was stationary when you started observing the motion. बिफोर दैट द सिस्टम वाज स्टेशनरी। जैसे ही आपने मोशन को देखना शुरू किया ना, तब ही ब्लॉक्स में एक्सेलरेशन आया। उससे पहले तक ब्लॉक्स रुके हुए थे, सिस्टम पूरा जीरो रेस्ट पे था, मतलब रुका हुआ था। जैसे आपने ऑब्जर्वेशन शुरू करी, जैसे आपने देखना शुरू किया, तभी उनमें एक्सेलरेशन आया है। ठीक है, तो कोई पहले से एक्सेलरेशन प्रेजेंट नहीं था, बेसिकली ये। सो यू हैव टू कैलकुलेट द acceleration, calculate the acceleration of the system and the amount of tension in the string. So I've given you the formulas, I've revised, I've just shown you the formulas. So it's very simple question, just put the value in that formula and get the answer quickly, everyone. इसको कोई गलत नहीं करेगा, और nobody should make mistake in this. I've just now shown the formulas to you. Okay, how do you calculate acceleration, कैसे निकालनी है, टेंशन कैसे निकालनी है इस तरह के सिस्टम की। तो स्पेशली आई डोंट वांट कि आप लोग कोई गलती करें, एंड इट्स प्रीटी सिंपल। ठीक है, फॉर्मूला आई नो याद नहीं हुए होंगे, फॉर्मूला याद नहीं हुआ होगा इतनी जल्दी, सो यू कैन हैव अ क्विक ग्लांस। ओके, एक्सेलरेशन का फॉर्मूला क्या है, m2 minus m1 upon m1 plus m2 into g। टेंशन का क्या है, 2m1 m2 upon m1 plus m2 into g। ये सब आप इतना टाइम बाद ज्वाइन करते हो, इसमें मेरे को रिपीटिशन कराना पड़ता है। ओके, क्विकली ट्राई टू सॉल्व दिस क्वेश्चन। आंसर, मुझे एक बात बताओ, आप लोग फॉर्मूला दिखाने के बाद somebody else has also joined? No. अच्छा, अनुराग है ज्वाइन, ओके ओके, अनुराग है ज्वाइन। अनुराग, आप तो थे लास्ट क्लास में, तो ये फॉर्मूलाज तो आपने कल भी देखे होंगे, तो आपसे तो हो जाना चाहिए बेटा फटाफट फॉर्मूलाज पर। ये है ना सर, देखे थे, पढ़ा कौन घर जाके, पढ़ा तो नहीं मैं भी गूगल पे ढूंढ रहा हूँ क्या फॉर्मूलाज हैं, ताकि मैं फटाफट वैल्यू रख के आंसर निकाल पाऊँ। ऐसा इतना टाइम तो नहीं लगता है, बाकी इतनी आसान आसान वैल्यूज हैं। अगर कोई ये सोच रहा हो कि सर जी की वैल्यू मैं 9.8 ले रहा हूँ, तो आप मतलब भैया जी की वैल्यू मैंने हमेशा बोला है, जब क्वेश्चन में गिवन नहीं हो तो आप 10 मीटर पर सेकंड स्क्वायर ले लीजिए। क्वेश्चन में जब भी ना गिवन हो जी की वैल्यू, आपको क्या लेनी है, 10 मीटर पर सेकंड स्क्वायर। 15 सेकंड्स और इससे लेट करोगे तो फिर क्या है, क्या ही सॉल्व कर रहे हो आप क्वेश्चन, फिर तो बोर्ड के लेवल की पढ़ाई कर रहे हो। Come on guys, फॉर्मूला ही नहीं याद है ना, यही तो दिक्कत आ रही है आप लोगों को, फॉर्मूला ही नहीं याद है। इसमें क्वेश्चन सॉल्व कैसे होगा? कितना भी टाइम ले लो, क्वेश्चन सॉल्व होगा ही नहीं। क्या क्वेश्चन दिया था मैंने? फॉर्मूला m2 माइनस m1 अपॉन m1 प्लस m2। ठीक है, अब मैंने आपको एक चीज बताई थी when I was teaching this formula, that it is not necessary that always m2 minus m1 will happen. It is not necessary. What you have to do is bigger force minus smaller force. So if you look at the previous question, m2, this is your m2 block, this 3 kg is bigger than what? 2 kg. So m2 is bigger. That is why I am writing m2 minus m1. If m1 would have been 5 kg, I would have written m1 minus m2. So this should be very clear with you कि मैं क्यों m1 minus m2 लिख रहा हूँ, मैं क्यों m2 minus m1 लिख रहा हूँ। ऐसा नहीं है कि सिर्फ m2 minus m1 ही होगा. It is not necessary that always and every time m2 minus m1 will come in the formula. No, m1 minus m2 can also come. The condition is that m1 should be greater than m2. Okay, so whichever is greater, whichever force is greater, you have to put it first. Subtraction कैसे करते हैं? बड़े में से छोटा निकालते हैं ना, छोटे में से बड़ा निकालोगे तो आंसर नेगेटिव में आएगा, है ना? सो इट्स सिंपल सब्ट्रैक्शन आपको ऐसे करना है कि आपको पॉजिटिव एक्सेलरेशन निकालना है, आपको ये माइंड में रखो। m2 माइनस m1 अपॉन m1 प्लस m2 इंटू जी। क्या है m2 की वैल्यू? अगर g की वैल्यू साथ साथ मल्टीप्लाई कर दो, m2 वैल्यू 3 है तो 3 इंटू जी नहीं करता, आप लोग शायद कंफ्यूज हो जाओ उसमें, है ना? यहाँ पे 10 लिख देता हूं मैं। दिस इज बेसिकली नथिंग बट 30 माइनस 20 अपॉन 5, which is nothing but 2 meter per second square. This is the value of your acceleration. इतना आसान क्वेश्चन, नथिंग मोर। व्हाट टेंशन क्या है इसमें? टेंशन का फॉर्मूला क्या बताया था मैंने? 2 m1 m2 अपॉन m1 प्लस m2 into g. So 2 into 3 into 2 upon 5 into 10. Okay, so 2 कितना हो गया ये? 2 into 2 4 into 2 8 into 3 24. 8 3s are 24. Tension is 24 Newton. Acceleration is 2 meter per second square. So your answer will be, I guess, option 1. Do you have any problem in the calculation? कोई ऐसा है जिसको कैलकुलेशन ना समझ आई हो? कैसे सर आपने कैलकुलेट कर दिया? हमसे तो हो ही नहीं रहा था इतनी देर से, और मुझे भी नहीं समझ आया आपसे क्यों नहीं हो रहा था। बट मेन थिंग विच आई कैन एनालाइज इज दैट आप लोगों को फॉर्मूला ही नहीं याद है, इसलिए कैलकुलेट भी नहीं कर पा रहे, बिकॉज ऑल ऑफ यू हैव ज्वाइन द क्लास आफ्टर 1 वीक। लिटरली सारे नए बच्चे हैं आज क्लास में। ओके, मलिनी हैज ज्वाइन। मलिनी ओके आप 3:30 बजे बोलते हो, ज्वाइन आप करते हो, है ना, 6 बजे के करीब। प्रसन्ना, दीपिका एंड सपना नो प्रॉब्लम टू सपना। सपना ने तो काफी टाइम से क्लास ज्वाइन नहीं करी है। आई कैन अंडरस्टैंड इफ सपना इज नॉट अंडरस्टैंडिंग, बट प्रसन्ना, अनुराग एंड दीपिका, यू टेल मी, इज दिस क्लियर? गुड इवनिंग माइनी। नेक्स्ट टाइम से कीप अ वॉच, आपको टाइम पर बताएगी कि 5:30 कब बज रहा है। Do you guys want me to explain why m2 minus m1g has happened and why I've written like that? Is it clear? मैं फॉर्मूला नहीं समझाऊंगा, बट मैं तो आपको जनरलाइज बता। कैन यू डोंट माइंड वन? यस आई कैन, आई विल नॉट माइंड दैट प्रसन्ना। Basically what you have missed, Prasanna, you have missed the derivation of these two formulas which I've written here. Okay, these two formulas which I've written, you have missed these two formulas because these were done in previous classes. A formula to calculate tension when two masses m1 and m2 are hanged. Okay, so you have missed this when the two masses m1 and m2 are hanged from a same string. This is same string. This and both of them are same string which is passing over a single pulley. Okay, and the pulley is fixed with this rod. This is a rod. Okay, so the pulley is fixed. So you have also missed the concepts. What is a fixed pulley and what is a movable pulley? You have also missed that. So you have to see the recorded session. But what main thing is, you have missed the derivation of this formula. How do I derive this? So you have to first of all go back and see again the recorded session. Okay, because it entirely takes a lot of time to explain how these shortcut formulas have been derived. Okay, so that you have missed. It has been derived with the help of these FBD diagrams. You see this, and I hope you attended the FBD class so you can understand that whenever a block of mass m1 is there, so the weight of the block m1g is always acting downwards because this is force due to gravity. Okay, and the tension in the string is upwards. Why? Because the string is inextensible. In an inextensible string, what happens is that the string does not want its ends to get stretched. Rasana, carefully understand why the tension is acting upwards. Once again, only for you. This string does not want its ends to get stretched. It is an inextensible string. Inextensible means which the length of the string you cannot change. Okay, the length of the string will remain fixed. That is the meaning of inextensible. So you cannot extend the length. That means the string will resist any force which will try to pull uh, the ends of the string away from each other, or any force which will simply try to change the length, try to extend it. So this m1g force, since it is acting downwards, it will try to increase the length of the string by pulling this end. Carefully see which end I'm circling. It will pull this end towards itself, towards earth, or towards downward, you can say. And if this end is going downwards, the tension in the string will act upwards just to prevent the motion of this end of the string along with the block. Okay, this was the concept which you missed. Now these are the two formulas, and in the question, m1 and m2 value is given to you. G, I've always told you, G you should take G is equal to 10 meter per second square, and then just it was simple question back after that. Okay, if you remember the formulas, you can simply solve it like this: m1 m2 minus m1 upon m1 plus m2. M2 is what? 3 kg. M1 is what? M1 is given to you as 2 kg. Okay, so 3 minus 2 upon 3 plus 2 is 5 into 10, value of G. So 30 minus 20 upon 5. Okay, 2. Similarly, this question. It's so easy. I want to start spring force, lekin na you guys are not even solving one question correctly. So I'm not getting confidence कि मैं अगले topic पे कैसे skip कर जाऊं. So these are 5 different pulleys. Pulley number 1, 2, 3, 4 and 5. ये 5 अलग तरह के पुली हैं. इन पुली से मैंने एक मास लटका रखा है. ओके, और इसको थोड़ा डिफिकल्ट बनाने के लिए एक काम और किया जा सकता है. 4 पुली से एक सिंगल मास लटका है. द 4 पुलीज 1, 2, 3 and 4 are connected with the bigger block of mass Ma, and the 5th pulley is holding a small block of mass Mb. Okay, so the mass of the smaller block is Mb and the mass of this bigger block is Ma. Okay, you have to calculate what? the ratio of the masses, such that this system should remain in equilibrium. What do you understand by the word equilibrium? I've already told you. In equilibrium, all the forces acting on an object are balanced. That is, they do not produce a net result. All the forces are balanced in equilibrium. There is no acceleration in the body. Okay, so that is what an equilibrium state is about. तो equilibrium में क्या है, सारी फोर्स बैलेंस होंगी, बॉडी का कोई एक्सेलरेशन नहीं होगा, बॉडी हिलेगी डुलेगी नहीं, उस पर लगने वाली हर एक फोर्स किसी दूसरी फोर्स से काउंटर बैलेंस हो रही होगी। तो उस कंडीशन में नेट फोर्स जीरो हो जाता है, इसलिए नेट एक्सेलरेशन भी जीरो हो जाता है। तो आपको कैलकुलेट क्या करना है, ए ब्लॉक और बी ब्लॉक के मास में क्या रेशियो है। ठीक है, डेफिनेटली सम डिफरेंस है, एम मास ऑफ ए एंड मास ऑफ बी, लेकिन वही आपको कैलकुलेट करना है कि क्या डिफरेंस इज द रेशियो ऑफ मास ए टू मास बी। एंड इसके लिए आपको टेंशन पता होनी चाहिए कि टेंशन किस में कहां एक्ट कर रही है। Do you guys want to try it here, or you guys want that I should give this question as homework? क्या चाहिए आपको, होमवर्क दे दूं ये क्वेश्चन या आपको यही कराना है? ओके, ट्राई। अगर आपसे किसी एक से भी सॉल्व होगा तो आई विल हेल्प, अगर नहीं होगा तो ये होमवर्क दूंगा कि सोच के आना कैसे होगा ये क्वेश्चन। आई विल गिव यू अ हिंट, इसमें टेंशन यूज होगा। सब टेंशन अगर आप निकाल लोगे कि स्ट्रिंग में वेयर द टेंशन इज एक्टिंग इन विच डायरेक्शन, that will completely help you to calculate the ratio. कोई ट्राई कर रहा है? ओके ओके, करो, ट्राई करो। Oops. Yeah. Okay, I'll help you. पता नहीं ट्राई नहीं करते हो आप बिल्कुल भी, है कुछ गलत वलत आंसर भी नहीं देते हो, कुछ तो लिखे एटलीस्ट कमेंट बॉक्स में, एक तो कोई लिखो। आपको टेंशन लगाना समझ में नहीं आया है, ठीक है, आपको मैं बताता हूँ हमसे क्वेश्चन क्यों नहीं हो रहे, व्हाई यू गाइस आर नॉट एबल टू सॉल्व द क्वेश्चन, बिकॉज़ यू गाइस फर्स्ट ऑफ ऑल डोंट अटेंड द क्लास इन अ सीक्वेंस. Okay, you skip the classes, and I've told you many a times that physics is connected. What you have read in the third chapter, what is that acceleration? किस चैप्टर में पढ़ा था आपने? थर्ड चैप्टर में, सॉरी फर्स्ट चैप्टर में पढ़ा था आपने, तो हमने मोशन स्ट्रेट लाइन में फर्स्ट चैप्टर स्टार्ट किया था, एंड देन यू स्टार्टेड यूनिट्स एंड डायमेंशन, तो उसको आप सेकंड मान लो, ठीक है। तो फर्स्ट चैप्टर की चीज आपके फोर्थ चैप्टर में काम आ रही है, एक्सेलरेशन आप वहां पढ़ते हो, मोशन इन स्ट्रेट लाइन, यू रीड द वर्ड एक्सेलरेशन, वेलोसिटी in that chapter, motion in a straight line, and this is what laws of motion. So I've told you entire physics is connected. Entire physics is connected. This acceleration will also help you in magnetism. If you guys don't revise your subject, then it's difficult. बहुत सिंपल सा लॉजिक है, अगर आपको चीज याद नहीं रहती तो आपको रिवाइज करनी पड़ेगी, और कोई तरीका थोड़ी है। अगर आपके पास कुछ हो ऐसा कि सर दवाई खाने से याद रह जाता है ना, कोई चूरन वूरन है आपके पास तो अलग बात है। तो फॉर्मूले आपको याद है नहीं, क्लास आप लोगों ने अटेंड करी नहीं है, तो इसीलिए सॉल्व हो भी नहीं रहा है। फिर आप यहाँ बैठ ही रहते हो बस कि सर देख लो सर आपके पास कितना टाइम है। ओके, एनीवेज, just try to watch the recorded sessions and be more answerable in class. You have to see the direction of tension. The weight of the MA block MAG will be acting downwards. Okay, due to this MAG force is acting downwards, the tension in this string will be acting upwards. In this string also will be acting upwards. In this string will also acting upwards. Okay, and this weight of the B block MBG will also be acting downwards. So tension due to this block MBG will be acting also upwards. So tension in all the four cases is acting upwards. Why? Because the weight of the blocks are acting downwards. So if I draw an FBD of the MA block, T tension is in this string. Okay. So tension T upwards. Two types of tension are in this are due to the second block. Okay, to the second pulley. Sorry, to the second pulley, there it is the total contribution of tension is 2T. Why? Because one tension is in the left string and the other tension is in the right string of the pulley. So the total tension will be 2T due to the pulley number 2. So pulley number 2 is contributing how much tension? 2T. Pulley number 3 पे आते हैं. Pulley number 3 is also contributing how much tension? Nothing, because the string passing over the pulley number 3 is connected directly to the pulley number 4. So if you include the tension due to pulley number 4, so it will automatically include the tension due to pulley number 3. यही तो constraint का फायदा. This is the added benefit of constraint, that all the same string is passing over all the pulleys. The same string is passing over all the pulleys. So you do not have to write the tension multiple times. जो string common है उस string में tension तो एक ही बार आएगा ना, ऐसे थोड़ी कि वो अलग अलग जगह से दो बार tension आएगा. If you understand my point. So total tension due to the third pulley has already been included in the second pulley and will included in when we calculate the tension due to the fourth pulley. Okay, third pulley की आपको अलग से नहीं लिखनी है. So total tension due to fourth pulley is also 2T. Why? Because two strings are there in fourth pulley. One is the left string, another one is the right string. Okay, and the tension T is acting in both the strings, and tension will be same in all the strings. Why the tension will be same? Because it is the same string. तो एक स्ट्रिंग में एक ही तरह की टेंशन आ सकती है. ठीक है, ऐसा नहीं है कि एक ही स्ट्रिंग में अलग अलग तरह की टेंशन होगी. Why? Because I've told you in the starting of constraint motion that the string is massless. String is massless. Massless string में एक ही टेंशन होती है हर जगह पे. जो मास वाली स्ट्रिंग होती है, स्ट्रिंग का अपना खुद का कुछ वेट होता है, उन स्ट्रिंग में अलग अलग जगह पे अलग अलग टेंशन होगी. दिस शुड बी वेरी क्लियर इन यू. If the string is massless, the tension will be same at all the points across the string. And if the string is not massless, and it has some mass, it has some weights, then the tension will be different at different points, because at different points across the length of the string, the mass of the string will change, and the mass of the string will also contribute to the tension at that particular point. Okay, so that will also I'll that is not asked in NEET, but I'll teach you that after this chapter is over, as in extra merit concept. Okay, वो भी मैं करा दूंगा, वो जेई में आता है majorly, but I'll teach you that. But you should keep this in mind, the tension will be same across all the strings, all the points in the string, because it is the same string. Okay, so tension T here, then tension T here, then tension T here. How much tension? 3T. Then tension T here, then here. How much tension? 2T more. So 2 plus 2 plus 1, 5T. Okay, so total tension due to the MA block is 5T. MA block, MAG is acting downwards, and the total tension equals to 5T is acting upwards. If I draw the FBD of MB block, so MBG is acting downwards and the total tension acting upwards is T only, because it is connected to a single string. Okay. So if I say that T is equals to MBG and 5T is equals to MAG, then you can say from this, what you can say, अब तो रेशियो दिख गया होगा, अगर T MBG के बराबर है और 5T MAG के बराबर है तो 5:1 का रेशियो है. ये चीज अगर अब तो I guess this should be clear. The ratio between MA and MB is 5:1. The mass of the A block and B block are in a ratio of 5:1. कैसे पता चला? हमने टेंशन कैलकुलेट करी, उससे पता चला इस रेशियो में टेंशन डिस्ट्रीब्यूटेड है एम ए ब्लॉक पे और बी ब्लॉक पे, उसी रेशियो में मास भी होंगे. Okay, so the ratio in which the tension is distributed across the blocks, in that same manner the masses are also distributed. I hope you understood. The main thing in this question was that you have to understand how the tension is acting. Okay, and why the tension is same. The tension is same because the string is massless. Okay, and the total tension which is holding the mass A block, okay, it is 5T. How 5T? I've explained. And the total tension which is holding the B block, mass of B block, is only 1T. So the ratio will be 5:1. 4:1. Malini close. शायद आपसे कुछ कैलकुलेशन मिस्टेक हुई होगी. Others? Is it clear? Malini, आपको भी क्लियर है अब क्या मिस्टेक हुई? Till the time you are answering, we can start something else. Okay, I'll see your responses, but I'll start the next topic. Spring force. ठीक है, अगला टॉपिक क्या है हमारा? स्प्रिंग फोर्स. Now, what is spring force? The force inside the spring is called the spring force. Spring के अंदर जो force होती है is called the spring force. Now, but this force is not due to some internal property of the spring. The spring force is not due to some internal property of the spring, but it is due to the external stimuli. Okay, the force inside the spring, which is called as spring force, is what should I say, generated due to some external compression or extension. Okay, just keep that in mind, that the spring force is not due to some internal deformity. Okay, it is due to some external action which you are taking, whether you are extending the spring or whether you are compressing the string. So due to that thing, the spring force is getting generated inside the spring. Okay, so two things should be clear to you, that it is due to some external action which we are taking on the spring. हम स्प्रिंग पे जो बाहर से एक्शन ले रहे हैं ना, उसकी वजह से स्प्रिंग फोर्स जनरेट हो रहा है. ऐसा नहीं है कि वो कुछ अंदर डिफॉर्मिटी आ रही है उससे हो रहा है. नो, इट इज ड्यू टू सम एक्सटर्नल एक्शन. जो एक्सटर्नल पर्सन, एक्सटर्नल ऑब्जेक्ट जो स्प्रिंग पे फोर्स लगाएगा, अब या तो उस फोर्स से आता है वो कंप्रेस कर सकता है स्प्रिंग को, एक्सटेंड कर सकता है. दो ही केस है ना. तो कोई बोले सर उछाल भी तो सकता है, तो उसका मैं कुछ नहीं कर सकता. जनरली फिजिक्स में आपको या तो स्प्रिंग एक्सटेंड होती हुई दिखेगी या कंप्रेस होती हुई, तो उसकी वजह से स्प्रिंग फोर्स आएगा. एंड स्प्रिंग फोर्स इज एन इंटरनल फोर्स बट ड्यू टू एक्सटर्नल एक्शन. ठीक है, स्प्रिंग फोर्स स्प्रिंग खुद लगाती है अपने ऊपर. ठीक है, दैट इज व्हाई आई एम कॉलिंग इट एन इंटरनल फोर्स. द स्प्रिंग इज जनरेटिंग दिस फोर्स from within the spring, and the spring force is acting on the spring. So that is why I am calling it an internal force, but it is getting generated due to some external action. You see the man in the figure, you see this man, ये दिख रहा है आपको? This man is trying to pull the string. When you are pulling the string, what you are doing? You are extending the string. When you are pulling the string, you are extending the string. जब खींच रहे हो बाहर की तरफ तो extend कर रहे हो ना, तो इस extension की वजह से एक spring force आएगा. How do you determine the direction? ओके, किस तरफ होगा स्प्रिंग फोर्स, इसका डायरेक्शन कैसे डिटरमाइन करोगे? ये आपने कॉमन एक्सपीरियंस भी करा होगा अपनी ऑब्जर्वेशन में. दैट द स्प्रिंग, आई हैव रिटन आल्सो, स्प्रिंग टेंड्स टू रेजिस्ट एनी काइंड ऑफ डिफॉर्मेशन. स्प्रिंग टेंड्स टू रेजिस्ट एनी काइंड ऑफ डिफॉर्मेशन इन इट. अब रेसिस्ट कैसे करेगा? हाउ विल द स्प्रिंग रेसिस्ट? If you are pulling, suppose this man, you see this man, suppose this man is trying to pull the spring outwards. Okay, this man is trying to pull the spring outwards. What will spring do? This is the natural length. This is the natural length of the spring. Okay, but this much the spring has been extended. Let us call this as this is x. Okay, so this man has been able to increase the length of the spring by x meters from its original length. Okay, 0. This was the original length. So the what will the spring do to resist this man, resist this deformation? Okay, the man has deformed the string. देखो ना, मैन ने क्या करा, खींच करके स्प्रिंग की लेंथ बड़ी कर दी, तो उसकी ओरिजिनल शेप तो डिफॉर्म हो गई. अब खींची हुई है स्प्रिंग, ओरिजिनल शेप में तो नहीं है अपने. तो स्प्रिंग कैसे करेगी? व्हाट विल स्प्रिंग डू टू to resist the force, to come back to its natural state? What will spring do to come back to its natural state? Spring will apply an opposite force, which is called as spring force, Fs. Spring force in opposite direction. If you are extending the spring outwards, spring force will be applied inwards. Okay, if the spring force is inwards, so the spring will come back to its natural position or to its original length. ठीक है ना. अगर आप बाहर की तरफ स्प्रिंग को खींच रहे हो तो स्प्रिंग फोर्स कहां लगेगा? अंदर की तरफ. स्प्रिंग अपने आप को कहां खींचेगी? अंदर की तरफ. भाई स्प्रिंग तो ये चाहती है ना कि भाई मेरी शेप को कोई चेंज ना करे. Nobody should change my shape. That is what the spring wants. Okay, spring wants that nobody should change my shape. So what will spring do? Spring will try to pull its end towards inside. So spring force will be inside when you are pulling the spring outwards. ठीक है. जिस डायरेक्शन में आप खींच रहे हो, जिस डायरेक्शन में आप एक्शन ले रहे हो, उसके अपोजिट डायरेक्शन में आपको रिएक्शन मिलेगा. So the reaction of the spring force is always opposite to the direction in which you have taken action. If you are compressing the spring inwards, okay, if you would have been compressed the spring inwards, so the spring force would have been outwards to return. ऐसे समझो, स्प्रिंग फोर्स क्या चाहता है? स्प्रिंग फोर्स चाहता है कि अपनी ओरिजिनल शेप में वापस आना. स्प्रिंग फोर्स, व्हाट इज द यूज ऑफ स्प्रिंग फोर्स? It helps the spring to return to its original position. Spring force helps the string to return to its original position. If you're compressing the spring inwards, the spring force will be outwards, so that the spring return to its original position. Okay, once the spring returns to its original position, the spring force is 0. Once the spring force returns to its original position, the spring force will disappear. Okay, because deformity has been neutralized. The spring is back to its original position. So that is why the spring force will also disappear. I hope the concept is clear. Now talking about the formula, let me just see if you are clear with the previous question. Prasanna, Deepika, Malini. Okay, Anurag is not responding about the previous question, and who is not responding? Sapna is not responding. Okay, Sapna, I have no problem. I can understand. So this is it. Talking about the formula. What is the formula of the spring force? The formula of the spring force is F is equals to minus kx. Okay. What is k? K is the spring constant. ये आपको always should be always given to in the question. K is your spring constant, proportionality or spring constant. It will always be given in the question to you. F is equals to minus kx. What does the minus sign indicate? Minus sign indicates that the spring force is getting applied in an opposite direction in which you have applied the force. Okay, if you have applied the force towards positive x-axis, the spring force will be acting towards negative x-axis. So this negative sign in the formula implies that the direction of the spring force is opposite to the direction in which you have applied the force on the spring. ठीक है, ये माइनस क्या दिखाता है फॉर्मूला में? कि जिस तरफ आपने फोर्स लगाया उसके उल्टी तरफ स्प्रिंग फोर्स लगेगा. अगर आप बाहर को खींचोगे तो स्प्रिंग फोर्स अंदर की तरफ लगेगा. अगर आप अंदर की तरफ स्प्रिंग को दबाओगे तो स्प्रिंग फोर्स बाहर की तरफ लगेगा. माइनस साइन बताता है डायरेक्शन ऑफ द स्प्रिंग फोर्स इज अपोजिट टू द डायरेक्शन ऑफ द अप्लाइड एक्सटर्नल फोर्स. क्लियर? व्हाट इज एक्स इन द फॉर्मूला? एक्स इज द चेंज इन लेंथ ऑफ द स्प्रिंग. ठीक है, जितना आपने स्प्रिंग की लेंथ को चेंज किया, जैसे हमने ना एक्स मीटर मान लिया, अगर हो सकता है एक्स कैन बी एनीथिंग, 2 meters, 3 meters, anything. Okay, so x is the change in length. If you are extending 3 meters, so if say k is equals to 10 and x you have extended the string to 3 meters, so the spring force will be 3 into 10, 30 newton in opposite direction, minus. Okay, 30 newton in opposite direction. This negative sign implies that the direction will be opposite. ठीक है? So I hope the formula and everything is clear about the spring force. It is a restoring force. Why it is called a restoring force? It is called as restoring force because it restores the original length of the spring. Why spring force is also called as restoring force? Why? Because it is restoring the spring. Restoring मतलब अपनी original state में वापस लाना. Restoring means that it helps to gain its original shape back. It helps the spring to gain its original shape back. That is the meaning of the word restoring. Restoring मतलब अपनी पुरानी shape में जो फोर्स लगाने से पहले जो स्प्रिंग की शेप थी उसी शेप में वापस जाने में स्प्रिंग की हेल्प कर रहा है, मतलब उसकी पुरानी शेप को रीस्टोर कर रहा है, वापस लाके दे रहा है, तो इसीलिए रिस्टोरिंग फोर्स भी इसे बोलते हैं. ठीक है, this is some example. Okay, that this was the original length. Okay, and you have compressed the spring by x meters. You can see compress the spring by x meters. This is external force. Okay, you are compressing. Okay, this is the direction of external force. This is the direction of spring force. Spring force will be outward. Similarly, this was the original position. Okay, original length L naught. Okay, you have extended the spring by x meters. Okay, you can see this is your x meters. You've extended the spring by x meters. This is the direction of external force. The direction of spring force will be inwards. Fs, this is Fs, spring force inwards. Okay. L naught is the natural length in the relaxed state. And these things have been repeated. F is equals to minus kx, this and that. Spring force of 1 is equal to spring force of 2. Okay. Now, what is this diagram try to imply here? थोड़ा सोचो. Can you guys think of it? What is this diagram trying to imply? ये diagram आपको क्या बताना चाह रहा है? देखो थोड़ा diagram को थोड़ा पढ़ो, नीचे क्या लिखा है. You will get an idea. Let me see if anybody is writing something. Nobody is writing anything. कुछ नहीं लिख रहा है कोई, किसी के दिमाग में आ नहीं रहा डायग्राम देख के. Nobody is trying to analyze the diagram. Okay, I'll simplify. I'll tell you. Time कितना बचा है हमारे पास? Okay, we have some time, 10 minutes approx. This diagram is basically trying to tell you that you have kept the same weight on both the strings. You can see the diagram. Spring 1 and 2. This is the spring number 1. This is spring number 2. So same weight. Okay, both the balls are exactly same in the size, shape, and weight. Okay, so the same object was kept on two springs. Okay, one spring has deformed more than the other. You can see that the spring number 2, देखो दूसरी spring जो है वो ज्यादा दब गई है वन के कंपैरिजन में. दिख रहा है ना, सेम वेट की बॉल रखी है दोनों पे, लेकिन जो सेकंड वाली स्प्रिंग है वो ज्यादा दब गई. So the second spring has compressed more with respect to the first spring. With respect to the first string, the second spring has compressed more. Okay. What does this indicate? This indicate that both of these springs have different spring constant. ये दो अलग अलग springs हैं, ठीक है, दो अलग अलग मटेरियल है इनके जिससे ये बनी है, एंड इनका स्प्रिंग कांस्टेंट जो है, दे हैव अ डिफरेंट स्प्रिंग कांस्टेंट. दे आर टू डिफरेंट टाइप ऑफ स्ट्रिंग्स मेड अप ऑफ डिफरेंट मटेरियल. Okay, these springs are made up of different material because we kept the same weight on both the springs. One of the spring, that is spring number 2, has compressed more. Spring number 2 ज्यादा compress हो गई spring number 1 के comparison में. So spring number 2 has compressed more with respect to spring number 1. That is why we say that both of them are different in nature. ठीक है, दोनों एक दूसरे से अलग अलग हैं. ठीक है, अलग अलग मटेरियल की बनी है, अलग अलग इनका स्प्रिंग कांस्टेंट होगा, क्योंकि अगर ये सेम स्प्रिंग होती तो ये दोनों इक्वल ही कंप्रेस होती. इफ दे वुड हैव बीन द सेम स्प्रिंग्स, बोथ ऑफ देम हैव कंप्रेस्ड इक्वली. ओके, स्प्रिंग 1 and spring 2, both of them have compressed equally. But this is not the case. They are compressing differently. Spring 2 has compressed more than spring 1. Okay, and that is the difference. Spring 1 has compressed by x1 meters from its original length, and spring number 2 has compressed by x2 meters from its original length. So that is, just a second, I have a telegram, but till I reply to that, just tell me whether you have understood the diagram. Oh, it's not necessary. Yeah. So that is what the diagram says. Now, if we say that the spring force is equal in both the springs, we observe this diagram and we said that the spring force which both of the spring is applying is same. ठीक है, अगर मैं ये बोलूं डायग्राम देख करके, ये आपको कंडीशन दूं कि इन दोनों स्प्रिंग्स में आई एम गिविंग यू कंडीशन दैट both of the springs are applying the same spring force against the deformity in their shape. ठीक है, उनकी शेप में जो डिफॉर्मिटी आई है, डिफॉर्मिटी मतलब शेप का बिगड़ जाना, जो ओरिजिनल शेप है उसका बिगड़ जाना, चाहे उसमें अब एक्सटेंशन हो या कंप्रेशन हो, उसकी ओरिजिनल शेप नहीं रह गई, कुछ तो डिफॉर्मिटी आ गई है, ठीक है, बिगड़ जाना, ओरिजिनल से डिफरेंट हो जाना। तो वो डिफॉर्मिटी जो स्प्रिंग के अंदर आई है, मैं कह रहा हूं कि उसकी वजह से लगने वाली स्प्रिंग फोर्स जो है, the spring force which is getting applied by both the springs is same, okay, because of the deformity in them. But you can clearly see that the compression is different. You can clearly see in the diagram compression is different in both the springs. So why, if I am saying that the spring force is equal, then what should be the case? How can it be equal? अगर मैं आप देख पा रहे हो डायग्राम के अंदर कि कंप्रेशन तो दोनों में अलग अलग है, यू कैन क्लियरली सी दैट द कंप्रेशन इन द स्प्रिंग 2 is more than spring 1. This you can clearly see. Despite of this observation, if I am saying that both the springs are applying the same spring force, ठीक है, ये ऑब्जर्वेशन के बावजूद भी मैं कह रहा हूं कि दोनों स्प्रिंग्स ने, स्प्रिंग 1 एंड 2, डिस्पाइट दिस ऑब्जर्वेशन दैट दे हैव डिफरेंट कंप्रेशंस, अलग अलग स्तर पे वो दबी, स्प्रिंग 2 ज्यादा दबी, स्प्रिंग 1 कम दबी, ठीक है, उसके बाद भी मैं कह रहा हूं कि स्प्रिंग फोर्स बराबर लगा रही है दोनों। तुम इसका मतलब क्या कंक्लूड करोगे? आप इससे ये कंक्लूड करोगे कि इनके स्प्रिंग कांस्टेंट्स डिफरेंट है, और डिफरेंट में भी कैसे डिफरेंट है, स्प्रिंग कांस्टेंट स्प्रिंग 1 का ज्यादा है, इसीलिए सेम फोर्स लगाने पे वो कम दबी क्योंकि उसका स्प्रिंग कांस्टेंट ज्यादा था, ठीक है। तो वो कम स्प्रिंग कांस्टेंट ज्यादा से क्या होता है, आप कम डिफॉर्मेशन में भी सेम फोर्स लगा सकते हो, जिससे आप उसको वापस ला पाओ उसकी ओरिजिनल स्टेट पे, स्प्रिंग को। Okay, to repeat this in English, if despite the observation that both of them have different compression, I am saying that the spring force is equal, what should this imply? This should imply that the spring constants are different, and since the spring constant of the spring number 1 is less, compression in the spring number 1 is less, that implies that the spring constant of spring 1 will be more, because more the spring constant, then it will be able to apply the same amount of force in less compression. Okay, let me give you an example. I am saying F is equals to K1x F1, and I am saying F2 is equals to K2 X2 and X1. Now if I am saying F1 is equal to F2, I am saying F1 equal to F1 is equal to F2, and I am also giving you the condition which you can observe is X. But you can observe that X2, the compression in the spring 2, is what? Less than compression in spring 1. So compression in spring 2 is less than compression in spring 1. You have two observations. F1 and F2 are equal. Okay, and compression in spring 2 is less than spring 1. Based on that, what you can conclude? You can conclude that the spring constant of the spring 1 must have been greater than spring constant of spring 2. ठीक है, क्योंकि देखो x1 तो ऑलरेडी ग्रेटर, x1 तो उल्टा लिख दिया मैंने, ये मैंने उल्टा लिख दिया, x2 ज्यादा है, माय मिस्टेक, एक सेकंड का, तो मैंने उल्टा लिख दिया, x2 is greater than x1. What is x? X is the compression in the string. X is compression. So if the compression in the spring 2 is greater than spring 1, if I'm saying x2 greater है x1 से, x1 कम है, so and then also the both of them are equal, then the only thing which is possible is that the k1 has to be greater than k2. if x2 is greater than x1, अगर x2 already x1 से ज्यादा है और तब भी मैं कह रहा हूं कि दोनों फोर्स बराबर हैं, तो एक ही कंडीशन हो सकती है कि k1 k2 से ज्यादा हो, ताकि मल्टीप्लाई करने पे f1 f2 बराबर आ जाए. So if I am already saying that x2 is greater than m1, so the only possible case that despite of the difference in the compression, the spring force are equal should be that the spring constant of the spring force which had lesser compression is equal to the spring force of the string which has more compression, is that the spring constant of the spring 1 should be greater than spring 2, because only if you multiply, इसको ऐसे बोलो आप, I am saying k1 into 2 is equals to, let's say, f1, and f2 is equals to k2 into 5. Okay, this is what I'm telling you. And now I'm saying f1 is equal to f2. Now I'm saying f1 is equal to f2. So इस case में how can you say f1 is equals to f2? Only if k1 is greater than k2. Okay, so only if k1 is equal to 5 and k2 is equal to 2, then only f1 and f2 can be equal. Okay, so if you put k1 value 5 into 2 and you put k2 value as 2 into 5, okay, k2 value 2, then only both of them will give answer equal to 10. ये इतनी सी बात मैं इतनी देर से समझाना चाह रहा हूँ. I hope आपको अब समझ में आ गई होगी totally that what I'm trying to say. Why k1 is greater than k2. Okay, from this demonstration, I hope you have understood this. ये ब्लैक पेज में लिखता नहीं पूरा. Okay. Basically, f1 is equals to f2 despite of the fact that f1 was k1 x1 and f2 was what, k2 x2. और क्या कंडीशन दी हुई थी मैंने कि x2 जो है ग्रेटर देन x1 है. दिस वाज द कंडीशन गिवन टू यू. सो इन दिस केस, डिस्पाइट दैट if f1 and f2 are equal, then you can conclude what, that k1 has to be greater than k2. and what you can take example as, f1 को हमने क्या लिखा था, k1 into 2 and f2 को हमने लिखा था k2 into 5, and then हमने क्या लिखा, f1 is equal to f2. So only if k1 is greater than k2, that is if k1 is equal to 5 and k2 is equal to 2, then f1 and f2 equal to, both can be equal and that can be equal to 10. ठीक है. यहां से रेस कर देते हैं, ब्लैक पेज पे अच्छा भी लगता है. स्टिफनेस ऑफ द, कितना टाइम बचा है एक बार दिखाओ. 6:29. okay, almost time is over. What I was trying to tell you is this: stiffness of the spring signifies how difficult it is to deform the string. K1 was what, stiffness constant. अभी हमने क्या पता है K1 के बारे में, K1 is your stiffness constant. So if K1 is greater, K1 what was K1? Stiffness constant. Stiffness means how much rigid is your spring. आपकी spring कितनी rigid है, कितनी tight है, कितनी solid है. How much solid is your spring? If your spring is more solid, you have to apply more force to give it the same deformation with respect to a normal, as compared to a normal spring. Okay, but if your spring is less solid, okay, even if you give small force, then also it will have a large compression. समझ में आ रही है आपको? स्टिफनेस क्या है, कितनी सख्त है आपकी स्प्रिंग, कितनी सख्त है. अगर आपकी स्प्रिंग सख्त ज्यादा है तो आपको बहुत फोर्स लगाना पड़ेगा उसको वही बराबर कंप्रेशन देने के लिए जो आपने एक नॉर्मल स्प्रिंग में कम फोर्स लगाकर ले आए. ठीक है, बट अगर आपकी स्प्रिंग बहुत हल्की है, बहुत कम सख्त है, बिल्कुल सॉलिड नहीं है, तो आप उसको हल्का सा भी फोर्स दोगे तो भी उसमें बहुत ज्यादा कंप्रेशन आ जाएगा. दैट इज व्हाट इट हैज रिटन. स्टिफनेस ऑफ द स्प्रिंग सिग्निफाइज, ओके, स्टिफनेस इज हाउ स्ट्रॉन्ग, how rigid is your spring, how difficult it is to deform the spring, and it is the measure of the inertia of the spring to resist any kind of extension or compression. This you already know. Stiffness means the measure of inertia of the spring to resist any kind of extension or compression. This ये तो हमने पूरी बात इसी पे चल रही है. Stiffness constant, okay, or proportionality constant. What does spring force do? Spring force is trying to resist any extension or compression in the length of the spring. Spring force does not want, spring force wants that the spring should remain at its original length, and there should be no deformation, there should be no extension or no compression. So what is helping in what is generating spring force? The stiffness in the string is generating the spring force. So we can say it is a measure of inertia. Inertia means okay, किसी चीज से fight करना. Inertia means to resist the change. Inertia basically means to resist the change. Okay, so yeah, with this I will end the today's class. I hope you don't have any doubts, and if you have some doubts, quickly you can tell me, or you can connect with me on the Telegram. Did you understand the concept of the spring force? Spring force को concept में quickly yes or no. अगर नहीं भी आया तो हम कल दोबारा कर सकते हैं. Just quickly tell me whether understood or not. All of you, quickly. Yes, sir. Okay, Malini, Sapna, and Deepika have responded. Listen, I hope you are also clear. If not, you can tell me on the Telegram. But this is all for today, and I will upload the notes on your. Time to time I keep on uploading the notes, so you should keep on checking. Okay, and you can also remind me if you want notes of some specific topic and I have not uploaded. You can remind me that, and we'll meet in the next class. Till then, goodbye. Take care. Okay. Be safe. All the best for zoology class.